Welcome to DBT-GA4 Setup Partitioning. I'm Damon. In this lesson, we're going to understand what partitioning does, recognize variable scoping errors, we're going to learn how to full refresh and select certain models, and we're going to learn where to find the key line in DBT Cloud error messages. Let's jump right in. All right, now we have this basic fact model set up. We need to partition it. So partitioning is an important performance optimization. So with analytics warehouses like BigQuery, when you query a column, it gets all of the values in that column. And now, if you're on a basic table, then that means that you get all data for all time. If you have a lot of data, this gets very expensive. What partitioning does is it creates a separate table based on your partition. Now, in the DBT-GA4 package, everything is partitioned by day. So here, table type partition, partitioned by day, and then we partition on a date field. So then we use that static incremental days variable. So remember, in our required variable static incremental days, and we look at those, in this case, the last three partitions when we're building our tables. And that's how we optimize performance. So now Google recommends that you have tens of thousands of values before you start partitioning. So if you have tens of thousands of page views a day, then you definitely want to partition that model. But if it's less than that, then it's more expensive to look up across different partitions. So I don't have many purchases. I don't have enough purchases to justify partitioning. However, I like to think of things this way. If your data is too small for partitioning to matter, then you're going to be in the free tier and you're not going to care about this little bit of inefficiency. If you're big enough to care, then if you're big enough for it to matter, then it will cost money and you need to do it. So either way, in the end, it's better to just do it and not think about it than to have sometimes partitioned event models and sometimes not partitioned event models. So it's just easier to keep things consistent. Now, when you're partitioning, there are two kind of main code blocks that you need to pay attention to. Now, here, actually, is this a better model? So this DIM-GA4 sessions daily model is a partitioned model. You see, first we have our partition configurations. So here we get the partitions to replace as the current date. So this is valid SQL. And then for every value in range static incremental days, we set partitions to replace is partitions to replace .append, and then this is valid SQL with some Jinja pulled in. So date sub, the current date, interval would be 1 and then 2 and then 3. So we would as strings, not as integers. So this is just get the last 3 days, and we assign that to partitions to replace. Now this is the config block. We see here we've got materialized incremental. So we had table before, now incremental. Incremental strategy is insert overwrite. This is a BigQuery specific configuration for DBT. Tags are optional, but since we have the incremental tag, we will use that. And then these partition by, you've got what field that you partition on. So DIM-GA4 sessions daily, If we go look dim GA4 sessions daily, we go into the details, we see this is partitioned by day, and partition on field session partition date. And that is set here, where field is session partition date. We start partition by day, and the data type of this is a date field, so we could use a timestamp if we wanted. And then we also have partitions equals, and then this partitions to replace that we assigned here. So this is the first part. And then the second part of the partitioning is we add this is incremental block and assign a where. So here it's the where has already come, but if there was no where clause, then it would be where, and then so stage GA4 events has an event date, not a session start date or session partition date. So, and the event date is in the partitions to replace. What this thing here is doing is called query pruning. So this is what limits the data to scanning just the last 3 days in our case, whereas these are what set up the partitioning, so that everything gets sent to BigQuery correctly. So if you want to, then the easiest way to start partitioning your tables is to grab this code and so we're going to be replacing that, but we'll just leave it here for now. And we've got our select statement. So select from, and we'll just fix the indents here. If it's incremental, this should be a where, not an and. And so stage GA4 event purchase, its date field is event date DT, so we don't need to change that. But this is something you need to be careful. It depends on where you're getting your data from. And then here, so we're not using session partition date, we're using event date DT. And then we get rid of this old config. And now we have partition table. Let's see what this error is. Yes. Now, here we come into a variable scoping issue. So this none type object can't be interpreted as an integer. Usually means you have an integer variable that doesn't exist. If it's interpreted as a string, it means you have a string variable that doesn't exist. And the reason for this is variable scoping. So here, static incremental days is scoped at GA4, but we're now using it in our project rather than the package. So what we need to do, we're going to move static incremental days out of the project, and we're just going to put it as a global level. Now, the other option is we could nest this in under our project and our package. And the reason you would do this would be, say you have several different packages and some of them end up using a variable of the same name, so you'd want to have them at different scopes. But in this case, I'm okay with the scope, the greater scope, and now our parser is happy. Okay, so now we hit dbt run and we select fact GA4 event purchase. Now this is going to be a little misleading. So we run this model and boom, that works. It looks good. However, when we go into BigQuery, we look we've got the fact GA4 event purchase model open. We see here it's not partitioned. So what we need to do is to run something called a full refresh. So we select fact GA4 event purchase full refresh. Now we refresh. And now we see this is a partitioned model now, and partitioned by day on event date dt. And so that is how you partition the model. Next, I'm going to create models for all of my events. So both standard events, recommended events, and custom events. And basically what I'm going to do is I'm going to take all of this, and then since we have this good working partitioned model, fact GA4 event page view, create, we type this in, we want stage GA4 event page view. Now all of these other things should all stay the same, and the advantage of putting our event specific data here is we just need to take off the bottom, so all of this stuff should be common to all events, and I don't have any custom parameters in my page view model, so I don't need to add anything here. But basically, if you have custom parameters, or if you're on a recommended model and it has some parameters that have been enabled, then you would add those to the bottom of this. But yeah, basically all you need to do then is to make sure you have the right staging model referenced so that you're getting page views and you're not selecting purchases in your page view model, and clean up the extra fields. And then we can do this for every event. So I'm going to do that offline and then go run this. And there we have it. I've created marts for all of the events that I want. So the eagle-eyed among you will notice I didn't do first visit or session start events. And that's because the dbt GA4 package's session table is more reliable than the session start event, which can sometimes not fire or sometimes double fire, and same with the user tables and first visit. So anyway, I have all of my models here, and we're just going to go. So we could do dbt run, but actually we're going to do dbt build, which does all of the package tests as well as the regular building of the models. So it builds and tests the models, whereas dbt run just builds the models. So I'll hit that. There, and now the run has completed and it has failed. So let's go look at these errors. So when you're looking at these errors, usually we want to scroll down to the bottom, and then your error message is this line from the bottom. So unrecognized name transaction ID. Of course, I put a transaction ID in a begin checkout event, so that's a typo on my part. I believe this is the same one. So those are copy and paste errors when I was copying the models over. I didn't edit out the transaction IDs, so I'll fix those. And then here is fact GA4 sessions, unrecognized name purchase count. Well, this is because we built the model first, and then now we built it again, but this time we had the conversions set in our config, our dbt project.yaml. We set up purchase as a conversion, and so for this last model, this one needs a full refresh. So I'm going to go fix these two, and then we're going to full refresh the 3 models. Okay, there, I've made the changes I need, and now I've got my command here, dbt run, select factga4 event begin checkout, factga4 event add payment info, factga4 sessions, and we're going to full refresh this time. So let's go hit enter. Right, and this is because the daily model also needs to be full refresh. So let's go dbt run select factga4 event sessions daily plus, and then we full refresh, and that's because I want dimga4, it's not event, so we want the dimga4 sessions daily, not the fact, and it's not event daily. So let's get this one correct. So you see here, this matched to no models, so you need to be careful when something doesn't match any models. It will say success, nothing to do. Here we went dimga4 sessions daily, which worked, but it didn't help. No, we wanted factga4 sessions daily, full with a plus, full refresh, and there we've built the sessions table and rebuilt the sessions table and the daily table and the client key and user keys that are downstream. And that's your basic fact models partitioned and all set up. To recap, we used partitioning to optimize our fact models. We've created fact models for all of our events, and we've looked at project, package, and global scope variables. We also looked at these partitioning settings. So partitioning splits data into tables so you can query a subset of your data contained within a partition. This relies on the partition replace assignment, which also gets referenced in the config block, and then is required within your query pruning in the isIncrementalDBT macro. We looked at full refresh for DBT runs. We looked at the error messages that we get when we do a DBT run. Specifically, the 4th line from last is the one that has the key error message. And finally, we looked at the select flag that lets you select models, and the plus sign added before or after that lets you select parents or children of that model. I'll see you in the next lesson.